Hi guys. So today we're going to review slope and equations of lines, okay? And so the first thing that we're going to start with is what kind of slopes do we have, right? So obviously this is not a coordinate plane, but the lines are going to have pretty much the same kind of direction, right? So here's what we call a positive, right? Positive slope. This one is going to be negative slope. This horizontal one is going to have a slope of 0 or 0 slope. And the vertical is going to have an undefined slope, right? And so for all four of these, okay, so M represents the slope, right? And so for a positive slope, is going to have just your regular number. It can be a number, it can be a fraction, right? So just know that it's going to be positive. So we don't really need to put the positive symbol on there. It's just if it's not negative, then we assume it is positive, right? And that's kind of the same thing for a negative slope. The only difference is now if we don't put a negative, like the actual symbol of a negative symbol, then we're going to assume that it's positive. So in this case, we actually have to add the negative symbol in front of your slope. Okay. For a slope of 0, you will literally see m equals 0, or we'll talk about more of what that might look like. And for an undefined slope, you might see it as m undefined or n undef or df, etc. Okay. So for the first two, for your positive slope and your negative slope, you're gonna have different types of forms, right? So it's gonna be in the form of y equals and then a number, we'll call it m, x plus b. That is what we call slope-intercept form. We'll talk more about that in the next couple of slides. But for our purposes, I'm trying to get somewhere. Again, slope-intercept form. Now the equation for horizontal lines, okay, so or 0 slope or horizontal slope, it's think about it this way, right? So if we start with y equals mx plus b, right? So even if we start there, once we put in, if we know my slope is 0, right? So if that's 0, what's 0 times any number? It's always going to be 0, right? So in this case, the equation for horizontal lines or for a slope of 0 is going to be y equals and then that b. And we'll talk more about that b, but really it's going to be y equals and then a number. And we'll just say it here. That is your y-intercept. And kind of the same thing for an undefined slope. The only difference is it's not going to go through the y-axis. It's actually going to go through the x-axis. So the equation for the vertical line, or an undefined slope, is going to be the x value, okay, x equals and then the number, and that number is the x-intercept, or it's just the line or the number that it goes through, okay? So down here we have our slope, and again, slope is represented by lowercase m. And there's different ways that we can talk about slope. There's different ways that you can calculate slope. There's different ways that you've seen slope, right? And so maybe the most common way you've seen it is rise over run, right? You might also recognize it as y2 minus y1 over x2 minus x1. And I want you to recognize that the y2 and the y1, we've seen that before. That just means your change in y over your change in x. And we'll talk more about that in a bit, right? So let's take a look at this problem here, right? So here we have 2 points, and I'm trying to find the slope. If I'm trying to find the slope of these lines, then I can do it one of 3 ways, right? So let me do this. So we said for slope, right, it's rise over run. It's also y2 minus y1 over x2 minus x1. And honestly, what I'm trying to get you is here, change in y over change in x. And you'll see why in a bit. Now, do you have to use that method? No, you don't. You can use whatever you want, right? But let's think about it. Am I always going to have a graph? No. And so since I'm not always going to have a graph, I can't really solely rely on this, right? Because if I don't have a graph, there's kind of nothing really to count as my rise over run, right? And so what that means as far as rise over run is the first thing that I would do is look at the general direction of your line. And in this case, we're going to have a positive slope, right? So if I know that m is positive, then really it doesn't really matter which direction I count in. Like, for example, if I count from B, 1, 2, 3, that's 4 units, right? And even though if I were to put a negative, well, it doesn't really matter what I put, because in the end, I know for a fact that after I simplify, my numbers should be positive, right? So that's what I mean, but it doesn't really matter as long as you know what kind of slope you're going to have at the end. And so in this case, if we do the rise over run, we start at A and go to B. How many units did we go up? 1, 2, 3, 4. So my rise or my change is 4. If my run is how many left to right did I go? So 1, 2, 3, 4, 5 units. And so here my slope is simply 4/5 or 4 over 5. Now that was just me counting, correct? And so I could have done the same thing using the formula, right? So the formula, I would need to know the coordinates of the 2 points. The coordinates are up there. And it, like, once again, it doesn't matter which one you call your first point or your second point. What does matter is that you keep it consistent. For example, you cannot say that's x1 and pair it with the y2. If you're going to call something x1, then its pair has to be y1. So if that's x1, that's x2, this is y2. So let's go ahead and substitute these numbers into my formula and see what we get. So that would be 1 minus a negative 3 over your x2, which is 3 minus a negative 2. Okay. Now, right off the bat, once again, there's nothing wrong with the formula. But right off the bat, some of you guys might have missed that, right? Because you might have seen the negative and it's just been like, oh, it's already negative. Well, no, that's not true, right? So in this case, we have 2 negatives. So it actually becomes 1 plus 3 in the numerator and 3 plus 2 in the denominator, and then we simplify. So when we simplify, you just add the numbers in the numerator, add them in the denominator, and then if you can further divide or simplify, then you do that. But in this case, on the numerator, we get 4. In the denominator, we get 5. Okay, so once again, my slope is just 4 over 5, right? And so, which brings me to the last thing here, right? And for our purpose sake, I'm going to rewrite the 2 coordinates here. And I'm going to write them such way. Okay, so now here, okay, so when we talk about change in y, change in x, right? So remember, x is on the left, y is on the right, or in this case, first and second, right? So when we talk about this, what I want you to realize is, once again, the direction does not matter, right? So let's pretend that we don't have this graph. So we don't have the graph. We don't know whether the slope is positive or negative, correct? But it doesn't matter which one of these two you call your first or your second point. What matters is you keep it consistent, right? So change in y is just the difference in y values, right? So difference in y values. So this is kind of what we're talking about here. Simply, we're kind of doing it in our head. So this is what I'm talking about. So if I trying to figure out how did I get from -3 to +1? Well, if we think about it, from -3 to +1, we have to go through 0, right? So from -3 to 0, that's 3 units. And then from 0 to 1, that's 1 unit. So altogether, it was the difference of +4 units. And we repeat the same process, and this time for the x, right? So how did you get from -2 to +3? Well, we know we added. How many did we add, though? So from -2 to 0, that was 2 units. From 0 to 3, that's 3 units. So altogether is 5. And now we got to worry about the symbol. So positive and positive is still positive, right? And so here my final answer, my final slope is positive 4/5. I understand they're all the same, right? Now, this might look a little bit more work, but honestly, it's because I rewrote these again, right? I didn't really have to rewrite them. Now, obviously, if we have a graph, we simply count. I agree that is the easiest way if we have a graph, right? If we don't have a graph to refer to, then we're kind of opted to use one of these two methods, right? Now, you tell me, do you want you can choose whatever you want. But understand that one might be a little simpler to use than the other, right? Because again, how easily is it to make that mistake there, right? Moving on. So once again, here, finding the slope, okay? Now, I'm going to go ahead and do this. Obviously, we have a graph, so we can simply count, right? So if we count, we'll get our answer, right? But my goal is to get change in y over change in x. So let's see how easily we could have done it, and then we can check our work by actually counting, right? So change in y from one y value to the next. How did I get from 4 to 1? I subtracted 3. That's my change in y, and I have to go in the same direction, right? I can't say, well, I'm gonna go from here to there. No, that's not correct. We have to go in the same direction. So how did I get from -3 to +3? Well, from -3 to +3, that means I added something, right? So I put a little plus. And from -3 to 3, we have to go through 0. So from -3 to 0, that's 3 units. And then from 0 to 3, that's another 3 units. And so altogether was 6. And from here, we simply simplify. A negative divided by a positive, right? So we're talking about just the symbols here. So negative divided by a positive means we end up with a negative. So my slope is negative, which matches the graph, right? And then we simplify. 3 over 6, or half of 6, is 1/2. So according to this, my slope should be -1/2, right? So let's actually count and see if that's true. Well, the first thing is I already know my slope is going to be negative because it's in a negative direction, right? So the second thing is count. So from P to Q, how many units did I have to go? 1, 2, 3. So we went down 3 units. And then from left to right, how many units did I go over? 1, 2, 3, 4, 5, 6 units. And we end up with the same numbers or the same slope, which in this case it's -1/2. Once again, we could have easily counted, right? Because we have a graph. But in the next examples, we're not going to have a graph. And so that's why, again, you can use whatever you want. Just letting you know that this might be a faster way, okay? So I want you guys to pause and like after you finish talking, pause the video and try these on your own. And really, honestly, try it on your own, whatever method you want. Once you have your answers, or you think you have your answers, then play the rest of the video so you can get the answers. So go ahead and pause now. All right, so I hope you actually paused the video, right? So remember, we can find slope one of 2 ways, or one of 3 ways, but in this case, we don't have a graph, so it's one of 2 ways. So it's y2 minus y1 over x2 minus x1, or what I'm encouraging you to use, change in x over change in y, right? So what's the difference between them? And so this right here is what I'm going to use because we should get the same answer, right? And so here we go. So to find the slope, so from my change in y, right? So I'll do this, change in y, change in x. So from 5 to 9, I added 4 units. From -2 to +4, okay, so from -2 to 0, that's 2 units. From 0 to 4, that's 4 units. So that was a total of adding 6, right? And so now we simply simplify. Positive over a positive is going to end up with a positive, right? And then finally, 4 out of 6, or 4/6, simplifies down to 2/3, right? So it would read the slope of AB is 2/3. Okay. And we're going to kind of repeat the same process with these 2 points over here. So I'm looking for change in y over change in x. So from -1 to +18. even though there's a big number, let's think about it. So from -1 to 0, that's 1 unit. From 0 to 18, that's 18 units. Altogether was 19, and we added because we went from a negative to a positive. Same with 7 to -12. Well, from 7, we're going from a positive number to a negative number, so we're going to have to subtract, right? How much do we subtract kind of depends on the difference between them, right? So from 7 to 0, that was 7 units. And then from 0 to -12, that's 12 units. So 12 plus 7, that's a total of 19 units. And once again, all we got to do now is simplify. We have a positive over a negative, which is telling me my slope is going to be negative. 19 over 19 simplifies down to 1. And so the slope of segment CD is equal to -1. Once again, you can use whatever method you like, right? But I hope that you can see that one method is much faster and hopefully a little bit safer than the other one. But once again, you can use whatever you want. All right, so I know you've heard it before, slope-intercept form. What does it actually mean? So let's break it down. So slope-intercept form, you get two things. And think of the slope-intercept form kind of like the most general form of an equation, right? So it has two things. So the M, we should recognize that it represents your slope. And the B, even though it has plus B, it can really be, it can actually be, the value of the B can be negative or it can be positive, right? It just, that's its general form. And that B represents the y-intercept. And remember, the y-intercept is wherever the equation crosses the y-axis, okay? So let's look at this equation here. So this 2/3, so one thing we got to clarify, and I should have clarified here, the M is the only thing or the only part that we say is the slope, right? Remember for these ones, M is the slope. There is no X here. It's just M, right? So please, please, please do not make the mistake in telling me that M, I'll even leave it in the, don't tell me that M is 2/3 X. That is 100% absolutely wrong. Okay, and the reason that it is wrong is because you're including the X. X is not part of your slope. It's just a number in front of the X. Okay, so in this case, my slope is is positive 2/3, which is telling me that my y-intercept, or my B value is 3. So y-intercept, remember, for the y-intercept, it has an X value of 0, and then the y-intercept, which in this case is 3. And so I have my first point. So the first point I'm going to do, if I wanted to graph this equation, the first point I would put is 0, 3. So I go, here's X value 0, here's 3. So I put my first point. From there, to get the other points, remember, the slope is telling you the direction and exactly which way the line goes, right? So that's telling you, starting from your y-intercept, or from any point really, each point is going to be exactly 2 units up and 3 units to the right, or opposite direction. So 2 units left, 3 units down, starting from here, right? So from here, I'm going to count 2 units up. So 1, 2 puts me at 5. 3 units to the right puts me at positive 3. So that's my second point. And I repeat that same process until I have enough points to draw my beautiful straight line, right? So from 5 add 2, that's 7. From 3 add 3, that puts me at 6. And we can repeat the same process going to the left. We just kind of reverse the direction, right? So down 2, left 3. And we repeat, down 2, left 3. All right, don't judge my line. It's very hard to draw a line in this. Let's pretend that's perfectly straight, okay? And so that, again, that's how you graph it if it has a pretty y value, right? So that's that, right? So if I started with the graph, I can actually also work backwards and find out the same information, right? So let's take a look at the next example. So for this example, we're looking to create or to write the equation in slope-intercept form. And so there's really two ways we can do this. We can do this, what we got to do is first we need the slope, right? And there's two ways we can do this. Since we have an since we have a graph, we can simply count to get the slope, right? So let's go ahead and do that. So 1, 2 units up, and notice how I have a positive slope. I know it's a positive slope because it from left to right it goes up. And then my run, or the change in x, so the difference between the x values, 1, 2, 3, 4, 5, and 6. And if I simplify, that is 1/3. So my slope my slope here is 1/3. If I'm looking for my y-intercept, right? So my b value, we'll put in parentheses, y-intercept. Remember, the y value of the y-intercept is, the x value of the y-intercept is always 0, which means it's always going to be on the x-axis, or on the y-axis, right? So this is my y-axis. Everything on this line has the x value of 0. So I simply go down and see where do they intersect, or where does it cross it. And in this case, it's at 1, 2, 3, 4. It's at -4. So now that I have my slope and my y-intercept, I can simply write an equation in slope-intercept form, which is 1/3. Now remember, 1/3 is the slope. We still need to put that x there. And we're really not going to write plus -4, right? Because whenever this situation happens, it becomes a negative. So it's just -4. Cool. And one more just to be safe. So once again, we need the slope and the b value, in this case the y-intercept. We know it has an x value of 0. And we simply count. So 1, 2, 3, 4, 5, 6, and 7. Notice once again how I have a negative slope. I know it has a negative slope because going from left to right, it's going down. So I can automatically put the little negative in front of my slope there. And as far as changing x, it's 1, 2, 3, 4, 5, 6, 7. It's also 7. So, and that simplifies down to -1. So I have, one last thing, I got to figure out where is the y-intercept. The y-intercept is where it crosses the y-axis. In this case, it's there. It's at -1. And so I have everything I need to write my equation in slope-intercept form. My equation is -1 x minus 1. You can or cannot, you can or you don't have to write the x. You will see it most of the time, most likely you will see it like this, right? If it's just a 1 in front of a variable, you're really never going to see that 1, but we assume it is there. So once again, if I didn't have all of this, right? So if I didn't start with the graph and I was just given this right here, this is telling me that if you were start at -1, right? So if I start here and the slope is -1, that means you go down 1, right 1, you would get the next point. And keep repeating and you keep getting the same points, right? So notice how if I were to repeat, I end up with that point that it gave me, right? And if I reverse the direction, that's left 1, up 1, the same thing happens, right? So the thing about lines is that they're never, once you have the slope of a line, it's not going to change, right? All right. So now let's talk about what happens, or what would happen with point slope form equations. So point slope form equations are in the form of y minus y1 is equal to m parentheses x minus x1. Once again, this m is going to represent the slope. So in this case, m is still slope. Now, for some reason, so a lot of people get confused with this. So the x1 and the y1 are the only ones you replace, right? So y1, x1, we actually replace that x and that y with an actual number, with an actual point, right? The y and the x that you don't replace, the y and the x that you leave and you don't touch, that it still have to be part of your equations, are the ones that don't have a little 1 next to it. Okay, and so let's practice, right? So if I start, I already know I gotta have that y, right? This point is my x1 and my y1. So here we have y minus My y1 is 3. My slope is 3. I still have the parentheses. I still have the x. Then I have minus a negative 2, or the x value. And once again, once that happens, it actually becomes positive. So y minus 3 equals 3x plus 2. Okay. And even though this looks a little bit different, right? It looks a little bit different because it's not in the form of y equals mx plus b, but we can actually get it in that form, right? But if they ever ask you to write an equation, that is good enough, right? That's an equation. But if they tell you to write it in slope-intercept form or simplest form, then we simply distribute that number in there and we simplify. So y minus 3 equals 3x plus 6, and then finally add this 3 over and we get y equals 3x plus 9, right? But either way, if you were to graph both of these, they give you the same thing. Okay. Almost there. All right. So here we have 2 points, and we'll call this point B. And I want you to write an equation. Okay. So I want you to write an equation going through. I want you to write the equation of the line going through these points, right? So the first thing is we're gonna have to find the slope, right? And in order for us to find a slope, remember we can do the y2 minus y1 over x2 minus x1, but remember that's just your change in y over your change in x. And so change in y, how do I get from 3 to -1? We subtracted 4. For my change in x, how do I get from -2 to +1? We added 3. And so my slope here is -4/3. Now, I have my slope. If I'm writing my point slope form, it's y minus y1 equals mx minus x1, right? So does it matter whether I use A or B as my point? It does not, okay? And I'll show you why it does not matter, okay? So remember, this is a line, right? So lines is not going to change its slope. It's going to go through the same points, whichever point you choose. And so let's do this. So on this side, I'll work it out both ways, right? And you'll see that we should get the same thing. So we're going to use A on the left side, right? So here's what I mean. So y minus my y value, which is 3, equals my slope minus a -2. So remember, we have to simplify here. So y minus 3 equals -4/3 x plus 2. If you can get to this point, you're golden. You're good. You're done, right? But I'm going to take it a little bit further just because I want to show you guys that it really doesn't matter which of these 2 points you choose, right? So for our sake purposes, and if you can't take this further, that is perfectly fine, okay? I just want to show you that we end up getting the same thing. So if we add 3 there, we get y equals -4/3 x plus 1/3. So this is my slope intercept form, right? I got here by kind of simplifying. And so I'm going to repeat the same process, but this time instead of using -2, 3 as my point, I'm going to use 1 and -1. And hopefully I get to show you that we get the same exact thing, okay? So once again, when that happens, we simplify. So y plus 1 equals -4/3 x minus 1. Once again, if you were to get to this step right there, you're golden, you're good. But we're taking it a little bit further to show you that we get the same thing. So if I keep simplifying, that means distribute. So that's -4/3 x minus 4/3. Subtract 1, let me back up. Negative and a negative makes that a positive. Subtract 1, we get y equals -4/3 x minus, just kidding, plus 1/3. And notice how in the end we get the same exact equation, right? Because it is. And so to answer your question is, it does not matter whether you use this point or this point in a point slope form equation as your y1 x1. Okay. Moving on. So just kidding, back up. So for this point slope form equations, we can easily find the slope because it's there, right? And the same for point slope, or sorry, the same for slope intercept form because the slope is there, right? But when an equation is not in either slope intercept form or point slope form, we can't easily read it off, right? If it is not in slope intercept form, or if it is not in point slope form, we can't really easily read it off, right? And so if you notice, both of these equations are not in point slope form. They're actually what we call in standard form. And so if I wanted to find the slope and a point, it doesn't matter which one, right? Because if it's on the line, it's going to go through that line. So a point on that line, I had to convert it to either one of these, right? So I will say this, going here is probably our easiest bet, okay? So notice how for this one, y it's by itself, right? So that in this case, that's our goal. So before we can divide or multiply, we got to get rid of all the addition and subtraction, right? In other words, I got to move this 3x over and rewrite it one more time. So we got 2y equals negative 3x. It's a positive 12. Next step is divide everything by 2. So divide that by 2, that by 2, that by 2, and we end up with y equals negative 3/2 x plus 6, okay? And so now we can easily identify the slope. The slope for this particular problem is negative 3/2. It's not negative 3/2 x, it's just negative 3/2. So my slope for this one is negative 3/2. Now we have to identify a point. And I will tell you this. The easiest point to find is either this, right? So if you remember, this is your x. This is your y-intercept, sorry. Your y-intercept, and this is your x-intercept. And what we know about them is that for the y-intercept, it has an x value of 0. For the x-intercept, that has a y value of 0, right? So in this particular case, I already have my equation, right? So I can simply plug in 0 for either y or x. Now, if I plug in 0 for y, that means I got to figure out what x is, and I'm dealing with fractions, right? So instead, if I were to plug in 0 for x and solve for y, well, what happens here? That goes away, and I get y equals 6, right? And so that's, I'm getting my y value. And so in this case, my point that I just found is going to be 0 because that's what I plugged in for x, and the y value I got was 6. And so those are my slope and the point for that particular problem, right? And so pause the video. I want you to try this one and then resume it to see if you get the right answer, okay? So I want you to find the slope, and I want you to find a point. I don't care what point you find, just find me a point on that line. Okay, so pause the video now, give it a try. All right, so I hope you actually paused the video. So once again, the first thing is try to get y by itself. So 2y equals negative 4x plus 8, divide everything by 2, we get y equals negative 2x plus 4. So here my slope is negative 2. And if I'm looking for a point on this line, I'm going to plug in 0 because I'm looking for the y-intercept, right? So y equals negative 2. Plugging in 0, I'm looking for that y. So that goes away. Y is 4. So the value I put in for x was 0, and I got a y value of 4. So quick summary. How do you find slope? Slope is a couple of ways. We have rise over run, which should be the easiest, right? You can always rely on the slope formula, which is y1 minus y2 over x2 minus x1. Yikes, I think I said that wrong. y2 minus y1 over x2 minus x1. And then what I'm trying to get you is to change in y over change in x. we have two types of equations. We have y equals mx plus b, where that is the slope and that is the y-intercept, and this is what we call slope intercept form. And then we have what we call point slope form, and that is y minus y1 equals mx minus 1, where that gives you the slope, and these two together give you an x1 and a y1. It just gives you a point, right? The second thing is, for a horizontal line, the slope is 0, but the equation looks y equals and then the number, right? A vertical line has an slope that is undefined, and the equation is x equals and then the number that it goes through. Okay. So go ahead and go on to Schoology, and you guys will have an assignment to do there. Good luck.